gain insights with their IAs, and how to improve them. All together now, let's go over our screen. I hope that we can see the screen.
Hmm.
And, right? So, Sarah, could you give us like a bit of details about your investigation?
So my IA was about the effect of like auxins, which are plant hormones, but I
Mm-hmm.
used like an artificial powder version of them, and I applied them on like these corn seedlings to see like the length of the radicle, which is a type of root. So I would measure
Okay.
like how it would affect the length of this root.
Okay. Okay, thanks for that. So I just have a bit of question. In terms of the auxin, you said that this is synthetic. Is it in powder form? Is it in a liquid form?
Powder form.
It's in powder.
Yep.
Okay. Um. All right. So, do you have any manufacturing details? Where is it from and things like that?
Uh, it might be on the material list. Wait, or
Okay.
like
But it's in the, yeah. So basically, you have that provided by the school.
yeah.
Okay. All right. So, these are just kind of follow up questions, just so that we will find it later. We will find these details into your paper. All right. Okay. So here is the rough draft, like the super rough draft of Sarah, and Sarah also um, has no title yet, probably, but that's fine. And yeah, so how else? How else can has your teacher gone through? Has your teacher given you feedback yet?
Oh yeah, she already did.
All right. Were those feedback already applied to this IA or not yet?
Uh, yeah, already edited it based on her
Okay.
feedback.
All right. All right. So based on her fee, so this is more of like more additional kind of like another eye to see for your IA, which I
Yes.
would happily oblige. All right. I'm just gonna check. Oh, you have 24 pages,
Yeah.
girl. Yeah, this is a lot. Okay. So remember what I have been previously or have I've been repeatedly mentioning. Um, um, IB examiners only look for 900, oh no, sorry, 3,000 words, and that is um give or take about 12 pages. Okay, I'm not necessarily saying it's 12, it can be less or more depending, because tables images are not counted as page numbers, so you can go a little bit over that, but give or take, it's the first 12 pages. So we want to make sure that everything is in the first 12 pages. So think about it as we go over your final submission. Okay. So
Hmm.
again, just so you know, for all our listeners or viewers or both, that I do not give a direct. I just give suggestions. I don't give direct editing, just so because it is not allowed in the IB guidelines on integrity. Okay, so it has to be. I can give you choices. I can give you examples, but the final choice is, of course, within Sarah. All right. So let's go over the first page. So let's go over your RD, your research design. Let me just kind of move this because it's getting in my way with that thing. All right. So with the research design right here, criteria is assessed. Students effectively communicates the methodology. All right. So again, it's also my first question to any of my students. Um, what are we hitting here? What boundaries or what mark um, are you aiming for your IA?
hopefully a 7.
Okay, we all hope for that, but we are
Yep.
going to work on that. All right. So, yes, of course, right? We always want to have the maximum grade that we want. So, we will make sure that we want to read over what we're looking, or how to get the best marks or the maximum score for the research design. The research question is described, so this is within the context of the research question. The research question is described within a specific and appropriate context. Could you tell me more about your research question? What I mean by that is, what is your manipulative variable, your IV, your reactive variable, and yeah. So let us know what is your research question,
So
how it's
my
structured.
yeah, my manipulated variable is auxin concentration. So the auxin powder that I bought, I like dissolved it using like chemicals and water, and then I adjusted it to like have like ascending concentrations. So that
Mm-hmm.
was like the manipulation, and my responding variable was the radical length that like corn seedlings produce after like I let
Okay.
them grow for 10 days.
You brew it for 10 days.
Yep.
Cool. Okay. That's within boundaries. That's within marks. Um, I'd like here that it is more focused. So, yes, you have some quantifying variables with your IV, which is 0 for your control,
Hmm.
1 2 4 5
Yeah.
milligrams per liter. And how will it inhibit the length produced by corn? So what we want, okay, let's go over our checklist, right? The research question, it's biology focused. So yes, it ticks the mark right here, right? The research question is clearly stated and precisely formulated. That's what we're trying to work on right now. Not quite, because um, your manipulated variable, we are not sure how you will quantify it. So in terms of length, what is what are you measuring? So yes, you're measuring length, but in what unit, and what is the tool that you are using?
Using a ruler and I think it was centimeters. Yeah.
Okay, so you use centimeters. So that's probably what can help.
Hmm.
Okay, that is what it can help in terms of identifying, or at least making it focused, so that your examiner or your teacher would know that both your independent and dependent variable are both quantifiable. And what is the as measured by? Okay, so if it's a ruler, you can use a uh, I would if it's available, a vernier caliper would also be something that you could use, etc. And then, of course, how long was the treatment, which is, you said here, 10 days. All right, that's within boundaries. So if you add that, that would probably check the preciseness of the formulation of your research question.
Hmm.
And let's see. The research question includes clear and specific manipulated and responding variable, or two correlated variables. So I could see that: concentration versus radical length. Okay, so we want to see any relationship or correlation, right? And the organism. Ideally, we go over. Ideally, we go over scientific name first.
Oh, okay.
Actually, we don't look for the common name in the research question. All right. You can also apply that to the title. The title, you should also use a scientific name. Um, I would also suggest that you write for the because of its formality. So in the title and the research question, write the complete genus and species of the species, And as you go over the background information, you can specify it once, and then like here, I think I could see it right here. This is the
Yeah.
first time you've said it here. So write it down as the complete name. I actually know what the complete name is. So I'm just gonna suggest it on your paper. Oh. Um, so when we write scientific name, the genus is capitalized, and then um, species will be all small letters, and we italize it. Oops, I made a mistake. I'm sorry. So italize like so. All right. And then what you can do, you can write it on a parenthesis like this, and then write it. Oh my goodness, what am I doing? Hold up. Write it like so, and across your paper, you can use the, because now you have introduced the shorthand, which is right here. You can write the shorthand all over your paper. Yeah.
Okay.
All right. So that is making it's making it more organized and also consistent that you are using scientific language. All right.
Mhm.
Okay, without really compromising the effectiveness of your communication. Now, description of the system, importance, relevance of the research question is clear. Why are we looking at that? So, upon reading your lengthy background information, right? So remember, guys, your research question or your research design, I should say, your research design from the first page, from the title to the method or the steps up to some kind of hypothesis that you will write. All of that is only 6 marks. So if you have 12 pages divided by four sections, what would that kind of cost you, Sarah? So 12
3.
divided by 4, about 3. So for the research design, from the title to the method, before you um, gather your data, your rough data collection and things like that, it should be no more or less, give or take, about 3 pages. Okay,
Mhm.
so woo, let's see right here. Okay, you are way above, right? Way above the minimum. Way, 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 way above. All right, so now here you even have your, yes, including your table 3. Let's give it a better name. That is your risk assessment. Your risk assessment also includes in the methodology, so make sure that you have less of that as you go over. So you have 11 marks. I mean, 11 pages, girl. 11 pages. So this is way overdone, right? So we have to make this a little bit more concise. Okay. So 11 pages is like the entirety of your eye. You're just getting started. So we need to tone this up a little bit. Okay. So let me ask you now, how do you think we can make this more concise? What is our plan?
Condense the research to like just like only like the parts that's really necessary as stated in the criteria.
All right. So as I go over the mark scheme, or at least the checklist that we're looking at, the research question should be clearly stated. We're done with that. How about here? Importance, relevance of the research question should be explained, and it should be concise. All right. How did we get into this point? What is the relevance? And um, add a citation. All right. So you're saying here about hormones. You're saying here this invention involves a radical length. So something to that effect. But what is the significance of, for example, your independent variable to growth of plants? Okay. So make it concise just to give the relevance of the system in place. Cool.
Mm-hmm.
All right. And appropriate, accurate, and relevant background biology of the phenomenon being investigated. So find some key points from your citations that are relevant to the study and make sense of that. Put it all together right here. All right, so let's see here. A singular root from the thinner seminal root emerged together, forming a primary root system. All right, so that explains the radical. But we want to talk about radical growth. So, uh, what constitute radical growth? So, I think that would be a more concise kind of way to put together a background, right? Rather than taking a lot of things. Like here, the radical uptake soil water for growth. Thank you for saying that. But is there in any way in your method that you used soil?
No.
So do you see the difference now?
Yeah.
You see the relevance, right? So yes, you got this, right? Yes, this is cited, but is it relevant? Right? So think about that and giving you like a way to reflect on the kind of citations you want to introduce to your background information.
Mm-hmm.
All right. It says here the context includes appropriate, relevant information about the variables. Yes, it's accurate. Relevance questionable, right? How about this? It says here oxide concentration is the investigation's manipulative variable. Thank you for letting us know. Auxin enters cells through influx carriers. This is correct. However, is it relevant? Right?
Yeah.
And function as transcription factors that manipulate gene expression for particular proteins. Again, relevance. Is this relevance to the study? Are we looking for transcription of genes? Are you going to explain that later?
No.
I see the hesitance. So, again, let's look back to your research question because you said, how do varying auxin concentration inhibit? So, you need to review again because this is what we're going to look at in your conclusion, right? We have to go back to your research question and are you answering how the varying auxins inhibit radical growth? Okay?
Mm.
So, um, I'm saying just make sure that your research question is written as connected to your data, and of course how you will interpret the data. Are they connected? Yes. Okay, moving forward. Proteins affect cell mechanism, promoting apoplast alkalinization and the influx of potassium and hydrogen ions. Okay, so a lot of big words, but are you directing us to the process? Okay? Does that make sense to you? Do
Yeah.
you have any questions? Okay. However,
Wait. About
okay.
the one for like the process, like the
Uh-huh.
like the first paragraph for research. Is there like,
First paragraph.
yeah, I should probably be like reducing the processes there as well.
Well, yeah. So again, you want to establish the relevance of your research and giving us appropriate background of your manipulated and reacting variables, so auxin and growth, and of course justifying that your method, okay, basically the method that you are going to use is relevant to the study.
Mm-hmm.
Okay, so for example, okay, this is exaggerated. So you say, I would like to investigate how auxin is inhibiting or how it promotes growth in terms of um, root. Okay? But my method is I'm going to go to a field. I'm going to go to a cornfield and get like 21 grown plant and like chop everything to see the root, and I will measure it by meters. Is that something is that something uh, allowed, or
Not
is it
really.
appropriate?
No.
Right? So it's so questionable, right? Like, is that even possible? I mean, is it, are you sacrificing 25 corn plant, like grown corn plant, for this experiment? And do I really need to uproot the entire like probably 3 meters of corn and use a meter stick and things like this? You know what I'm saying? So you just want to make sure that you are, of course you're not going to do that as a method, right? So here, talk about your method in such a way that it is safe to do, that you have that the process, probably you have looked into a the same experiment in a peer reviewed source.
Mm-hmm.
Okay, some of your classmates has done that, which I applaud, right? So is this something that you have probably invented or whatever? But basically the IA is, what we're looking for is that the method is based on a an already done lab, because we're expecting you to do this in a school laboratory, at least in this kind of design, right?
Yeah.
But if it's something that, yeah, because it's allowed, like as written here on the mark scheme, there are some schools that are placed within a farm, right? Like I think there's a nice high school somewhere in Kobe where it's a specialized school for farming. So they are exposed with cows for the wagyu, um, like wagyu herding. So that's appropriate to their setting. But as you are, situated in a city, then it has to be something that you have created in a lab setting, or at least that's what you have explained here, right?
Yeah.
So you just want to establish it, that that is appropriate, and where did you get that inspiration from? Cool.
Mm-hmm.
So, and that's all you need, actually. That's all you need for the background information, right? So we're looking for citations of the relevant to contextualizing the information you have provided, direct relevance of a theory. So here it says context includes a description of a known relationship of the variables being investigated. So is this something that is common knowledge already? Did you read it somewhere in your textbook, or somewhere that the information can be um, uh, cited? Okay, so how relevant is your information? Cool? Or how reliable? There is a scientifically accurate hypothesis predicted in the relationship. If it's relevant, citations again of contextual informations are provided. So you did provide a lot of that. It's just that it's way too much as I expect as well. But just look into its its relevance. Let's just see one here. The particular auxin used in this investigation is NAA, or naphtha lineacetic acid. Definitely, this is um, connected. It as its growth regulation is concentrated in plant rooting. Very good. And therefore suitable for measuring its effect on radicals. All right. So this sentence alone, I'm going to highlight it, okay? I'm going to highlight it in orange. I mean, in, let's say, green. That means that it's a go. It's like, okay, this is relevant. So definitely this is going to stay.
Hmm.
Okay?
Yep.
All right. This one, previous studies examined how auxin types affect plant root induction, including Alentera reinekii. That I do not know. But, you can say state relevance. I'm not sure. But for now, all right. The responding variable is radical length as part of the primary root. Studies suggest high auxin concentrations also shorten its length. So is this what you want? Because you said inhibiting, right?
Yeah.
You mentioned here it's inhibition. So we are looking at how auxin, as the auxin increases, what happens to, because you said inhibition. So are you saying, or at least correct me if I'm wrong, to my understanding, that you're expecting the increase of auxin will shorten the root growth?
Yep.
Okay, cool. So then this is relevant. Yeah. All right. So radicals are measured through the cent with rulers. All right. Or what are we? How are we measuring? How accurate are we? Are we using You mentioned centimeters, right?
Hmm.
Okay. So centimeters, while scanner programs to precise measurements of volume. So is this do you actually need that? Right? I don't know. Did, did we did we measure volume? I'm not sure. But you see how, like, it's something that probably you don't really need.
Hmm.
Nah. Okay, because I understand some students are making direct quotes, but remember that um, examiners and your teachers are looking for conciseness, relevance, as well as you don't want to put way too much direct quotes, right? They want, or at least we would like you guys to paraphrase.
Yeah.
Yeah?
Hmm.
All right. Previously, biologists have studied how nitrogen amplifies radical inhibition in rice. I don't even know. Okay. So, expectations. You're saying here your expectations. Are your expectations somehow your way of saying this is your hypothesis?
Yeah, and like the scientific like background of it, just like why this relationship is known.
Okay. So, it doesn't necessarily have to be a separate paragraph. It can be like put into this. All right. Say it is already assumed that the concentration of radicals, the correlation exists in increased auxins. So, as you can see here, you place it in a different paragraph, then you're just kind of um like saying it again. You're
Yeah.
being redundant, right? So let's take note of that. Actually, the best, that's why I'm glad that you're doing this with me, because like you're seeing like a different angle. If I am not available, you can also utilize your classmates as peer editors, right? So this
Mhm.
is something that you guys need to look into. Like, am I blabbering? Am I already blabbering by repeating same information over with a different citation, things like that? So overdoing things can also be like a pitfall, and you can actually lose marks from that. Okay. Other studies have discovered that raising levels reduces primary root length cultivated in a growth media. Given my research, I hypothesize that increasing NAA concentration will reduce corn high levels. Cool. But again, restructure in such a way that this is concise. Okay, so you are hypothesizing here, so might as well give yourself a hypothesis. And you, because right now it is now required, the new syllabus, or at least in your batch, you are now required to do a statistical analysis. So write hypotheses will um, that will signal teachers that you are um, doing a statistical analysis. So how do you write that? How would you establish in the simplest form that you are undergoing um, a statistical analysis with your hypotheses?
Uh, I can reference the test I'm gonna use, like the Pearson's correlation coefficient.
Do you but the how do you write hypothesis when you do a statistical analysis?
The null and
Yes, right. So do you write it as so, like H0 and H1?
I have it. It was like the same as Takeshi's, where it was just no hypothesis and alternative hypothesis.
Mm-hmm. Yeah, yeah, yeah. Why? Okay, I'm having a, what do you call this? I'm having a feedback, but nevertheless, control bam. Ah, this could have been easy, but why am I doing this? No, not bold, not bold. I want this not bold, but I want this as subscript. There. Okay, so writing it in such a way that you write the alternative and the null hypothesis. There's no relationship and there, but before you get there, right, you want to make a, you kind of walk us through how we got to this hypothesis.
Mm-hmm.
Do you get me?
Yeah.
Okay, so that is that. Wait up. Uh-huh. All right, and bam. Cool. All right, now with your variable, manipulated variable and your reacting variable, or your responding variable, sorry, and your controlled variables. Cool. Way too long, right?
Mm-hmm.
So you remember that you have already introduced that in the background knowledge. So just just give us the like give us like what is the range, what range are we, what are your concentrations, how did you prepare the concentrations, what did you use, you know what I mean, like I've seen a formula here, so I think this is how you measured. That's cool. All right, but this is a checklist for you to um, kind of help you to be concise. Number of range of levels manipulated are suitable. So establish why this is suitable. Was were So you said that there will be 5 levels of concentration. Remember that 0 is not a concentration, honey.
Oh, yeah.
Okay? 0 is control, right? Without anything, this is how it will grow. But if you add this, and this is the growth. Do you notice something strange right here? So it's 0, 1, 2, 4, 5.
That I'm
I think
skipping 3 milligrams per liter.
what's the reason? Do you have a reason?
Yet like my teacher advised me to make it like to skip 3 just so I could like get to like the extremes kind of for like inhibition. Like I wrote below, it was like levels were selected to exceed 2 milligrams per liter, which a few
Okay.
other experiments determined was optimal. So I just wanted to make it like
However, okay, if you did that, all right, if you did that, then um you see, any data that you got from zero is not part of your data. You get what I'm saying? Because this is just an
mhm,
indicator. This is an indicator without it. This is a control. This is a, you know what I mean?
yeah,
Yeah? So this is the control. If you have established that, you told me what is the ideal? What did
two
you say is the
milligrams.
ideal? 2 milligrams, right? So 2 milligrams. Then did was that explained here? In the
No,
no, right? Do you see what I'm talking about? Why are we guessing it now? So I think there should be something here in the background, right?
yeah,
The back, yeah, measure in the background that this is the ideal, and then I want to go a little over, but why are we going over twice as much? Establish that. So I want you to rethink that. All right. So again, zero is not going to be part of any data. Like, this is not going to be part of your data. It's more like just an indicator. However, 1, 2, 4, 5, with 5 repeats, it's only 20. In order for you to get a little bit higher, it has to have about 25 or more.
I
So
did
think
seven
about that.
trials for each.
But why? What? Say it again.
I did 7 trials for each level.
Is there is there a um is there a basis on that? Is this something that you have thought of just to get the date, the number that you wanted?
Just to because like the control like to ensure accuracy because like the zero is gonna count as a control and
Okay, so despite 5 and 7, that's fine. All right. So increasing repeats um, has been thought of. So that's something that we would like to read here in the background, right? So this is the background of your method. Okay. So that's
mhm,
something that you need to look into, like establish why you come up with 7, and if 2 is the highest, we're going 50% and 100% over what you have researched is the optimal. So think about that in terms of appropriateness.
mhm,
Okay. Because if I were to be precise, if I know that I will go over, if I would go over 2 milligrams, right? And I've researched somewhere, I would look into like somewhere close. If it's ideal is 2 milligrams, all right, I would see if it's 1.25, 1.5, 1.75, 2, 2.25, 2.5. So I have 5 data points going towards going over, a little over, and I want to see how it goes. So am I allowed to be that precise? Is 5, you know what I'm talking about? So
yeah, no,
am I gonna, you get my drift? Like, am I
yeah,
gonna get that data? But nevertheless, this is what you did.
mhm,
So there's really no point redoing, right? Like, you're gonna take 10 more hours. So that's just what I'd like you to think about. This is already, I am assuming you're already done, and you've already obtained the data that you would like to process. All right, so let's go over. So 0, 1, 2, 4, 5, measured once through a pipette. And then levels were selected to deliberately exceed, okay, 2 milligrams. So that's the 4 and 5. Which other experiments determined to be optimal for corn development? which other experiments determined? Okay, so think about this, all right, because it's giving me doubt. How it's written, it's open to interpretation. Okay? Other experiments determined to be optimal. So then why did you get this citation if it's doubtful? You know what I'm saying?
Mhm.
So think about how it's written and how it is helpful to create a concise and justified citation. All right.
Yep.
For inhibiting radical growth, additional of 3 milligrams concentration was omitted in favor of a more extreme range of NAA levels, progressively strengthening inhibition. Once again, 4 is 100% over, and 5 is 150% over. Okay? Crazy. But nevertheless, this is what you did. I'm just saying. All right. So I'm not saying it's wrong. I'm just saying there's got to be a better way, but you already did it. So, never, you know what I'm saying?
Mhm.
The dilution formula below calculates the amount of zero point 0.1 milligrams per ml solution pipetted to create solutions of manipulated concentrations. All right. Okay. So zero point 0.1 per liter. So your final volume of solution is about 200 ml. And 200 ml is enough for your site for your work?
Yeah.
Okay. So I am also okay. Basically, when in this subcategory in your background, talking about your manipulated and dependent variable, it's think about it in terms of, again, fluidity and conciseness. Okay, how did we jump into this concentration? Is it, you know what I'm talking about? Like
0.1.
reading, yes.
Yeah.
Like, how did we go from telling us the manipulated variable of auxin, and then we went on creating this dilution? Have we, did you, was it like the dilution formula below calculates the amount? I get that this is the formula. Are you telling us, like, I'm just getting lost. Do you know what I'm saying? Like,
Mhm.
how did we go from here? How did we go from now making the concentration? Because I thought that you are only introducing us to the dependent, independent, dependent variable, and control variable. You know what I'm talking about?
Yep.
So, what do you think can be done with this?
Sort of introduce how I'm gonna turn the NNA powder into this like solution, and then introduce like how I'm gonna pipette it as well.
Okay, remember that you are getting, what page are we? We are now on page 3 here, okay? Remember, you're still gonna write from your 3 pages. You are still expected to write your methods. You're not there yet. Okay? What I'm trying to say is you're I think this is way too much.
Hmm.
Yeah?
Yep.
And then you're talking about the variable, and then there's an image, and we're already on page you it this is just too much. My suggestion would be a my suggestion here would be a table. Create a table, because table simplifies things, making things organized. One table is about the manipulated variable. Why? What is it? Like who, what, when, where, how. Like, what is it? why did you use it, and how did you make the concentration. This is the formula, and this is how I got it. So
Mhm.
it can be, uh, it doesn't need to be this much words.
Okay.
Okay. And then the next table, or the next column is like, this is the dependent variable measured by, and this is the tool that I used, right? And this is my control variables. These are the five control variables. And I think this is what you did. Where's the control variable? Right here. All right. So you controlled, we're looking for about five. Okay. Control variable is what the volume, right? As much as possible, we use words that can be measured. Amount is not measured, right? But volume we can measure. What is the unit of measurement for volume?
Uh,
It's right here. It's,
yeah, milliliters.
yeah, right? Why don't you just say volume of water?
Okay.
Right? Because at least we know that the volume has been measured, and it's measured by milliliters. And what is the significance of why you have to control the volume? Because water reduces interferences of radical development. Okay, cool. All right. Size of the seeds. Similar seed sizes would be selected for the experiment. Okay. By what? Oh, how would you do that? Are you gonna measure it? Are you measuring it by eyeball? Are you gonna eyeball it? Are you gonna measure, like, how are you gonna make this? How do you assure me that this is um like consistent? Did you use a measuring tool?
No, I eyeballed it.
Yay!
Yeah.
Okay, because I could have been like no less than or no more than 4 centimeters, or I don't know, or like no more than 5 millimeters. Where, you know what I'm saying, that could have made this better,
Yeah.
right? So, or it can be some form of like a criteria, like it should be with between 3 to 4 millimeters, right? So
Mhm.
anything, because if it's too small, if it's 2.4, nah, i can't I can't count that, right? I'm only within this size. Yeah.
Mhm.
All right, light duration. Hold up. Do you need light? Do you actually need light for roots to form?
Uh, Not necessarily, but like it was
It's
part of
not,
like the condition.
but it's not, right? Because roots do not have chlorophyll, correct?
Yes.
So this is actually, like, if you write this, I'm warning you, if you write this and I am an examiner, I'm going to give you less mark, right? Because in root growth, you do not need sunlight because roots are usually underground, especially corn. Got it?
Mhm.
If it can be a different species, again, there are species that the roots are outside, like it's not in the ground. I would consider that. But because you mentioned that you are using Zea mays, I know that the roots are underground. So you don't need light. Yeah?
Yep.
So again, for if I were looking at it, I would this so that's an example of, like, watch out, because it doesn't mean that you write it, it's right. Okay, so let me just put a red mark right here to rethink. Temperature, seeds will germinate at room temperature. What is that room temperature? So how was it measured? How is it controlled then? There is no temperature specified here. Yeah.
Mm-hmm.
All right. What temperature are we looking at? Is it between this, or did you specifically um, kind of control the temperature that it's 25 degrees for 10 days? Did it range from this temperature? Because you said that you controlled the temperature, right? What does
Yep.
that mean? Right? So how did you establish that this temperature is really controlled? So here, this is how teachers look into it. So if there's no measuring indicators, then that means that this is not a good control. Yeah.
Yep.
So think about the marks that are weighing down in the method, in the methodology or the research design. Growth duration will be measured in 10 days. Is this, what is the process here? Was this is this yes, 10 days is 10 days is measurable, but is this suitable? Did you look into any um like experiment that says 10 days you will find something?
I think I had like cited information that it was
Okay.
like around 10 days to like germinate.
Okay. Yeah, good that you have like 10 days germination. It's just that I don't know where that is.
Yeah.
Okay, so just make sure that that is substantial, or that is a specified in the background information. All right, so that's that. And we are in, okay, reacting variable. Oh, wait a second. Okay. Responding variable, this will be measured in, yeah, you again, you don't need to, yeah, 7 trials of data collection. I don't know. You'll edit this, yeah?
Mm-hmm.
Duration of radical in corn. So this is the radical after 10 days, kind of.
Mm-hmm.
Okay. All right. All right. So this is the control. What is the VM? What is this? Same ruler. Okay. Same ruler measurement, same equipment, same corn seed. All right. So it's, yeah, look into it, that we're looking for at least 5. Over that is great, but just make sure that they are measured. You give us a reason why it should be controlled and method of control.
Mm-hmm.
Cool?
Yep.
All right. Um, the background information and method approach is well described. The methods of measuring variables are justified. So remember that words, right? So you need to justify that this is suitable. 7 repeats is suitable. Yada yada. Okay. Collecting relevant data, the manipulated variable is correctly identified with units and levels. This is there is justification of how the levels are manipulated were chosen if relevant. Why did I write it twice? All right. A quantifiable responding variable is correctly identified. There's justification on how responding variables was chosen. Important control variables are identified with potential impact. Okay, I justify why this is impactful. The justification is positive and negative control group if relevant. There are sufficient validity measures to ensure that the method measures what it is intended to measure. So if you're measuring temperature, how could you justify that you're actually measuring it within the boundaries that you mentioned? Cool?
Mm-hmm.
All right, now let's collect data. The number and ranges of levels are suitable. Interval of frequency of measure is and responding is suitable. Okay, so this is to me something that you need to um, explain further. Okay, because giving it an extreme, you have to, how extreme is extreme? 100%. Like for example, if if I'm giving you medicine, and for 15-year-olds uh, well, of course, you're not a plant, but just imagine yourself, you're a plant. And I say, okay, they say that the ideal measurement of medicine for you is 2 tablets. You know what? I'm going to give you 4. Let's double it. Let's just see what happens. You know what I'm saying?
Yeah.
So, yeah. But again, nevertheless, you've already done it. So again, I'm giving you hints on what can you write on your evaluation. Okay? So think about that. Oh, this is something what I could have done. Instead of doing that, I should have done this. All right. Number of repeats. Variable are suitable to ensure reliability and allows for statistical analysis. The precision of measurements of variables are suitable for the investigation and allow for statistical analysis. Okay, so with the numbers that you provided, seems to me that it can get into we can analyze data. Wonderful. Um, I just have an issue with regards to your materials risk. So remember what I said before, that in communication, there should be no breaking
Oh,
of
yeah.
tables, right? So this is already a violation of that. If it happens once, it's not a problem, but if it happens consistently, that is like 1 mark off through communication on the, I think this is the data analysis um, section. Okay, moving along. Okay, this can be improved. This list can be improved. Yes, times 40, one times 1 gram. Did you use 1 gram in total of this NAA powder?
Yeah.
Just 1 gram.
Yeah, because the
Because,
concentration was in milligrams per liter.
but there's, okay, 5 milligram, 4 milligrams. Okay, got it. Okay, so just 1 gram. Rainbow spatula. Okay, any, any, tools that you measured using that has numerical value must be measured for error. Okay, so let's see.
Well, I have my
Uh,
uncertainty table like it below.
like right, but it's also good practice to say plus, 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 minus, minus something, something. Anything that's, it's making it consistent. You're talking about?
Hmm.
Okay, pipette. Yes, this is a measuring tool. So this is a measuring tool. Measuring tool. Let's just put orange. This is a measuring tool. What else is a measuring tool? This is a measuring tool. What else? A measuring tool. Measuring tool. Measure. Ruler, of course. Because I want to ensure that you really used a centimeter ruler. Okay, there. Another. Okay, so remember, you first violation, this is second violation, right? I have 3 strikes. So if you did it one other one, I'm gonna mark 1 point less in communication. If that happens, you know what I'm saying?
Yeah.
Just to be objective. Okay, candidate code. Oh, wait a second. Is that your corn seeds?
Yeah.
And it's colored?
Yeah, I don't know why. It's just the type that I bought.
It's good. It's good. No, I think so that, I don't know, it's easy to see, but that's cool. All right. All right. Okay, methodology, similar protocols and procedures, experiment replicated methods of another study. Again, this is this is a allowed, all right, on the effect of phytohormones in inducing corn plantlets. Replication involves replacing corn seeds in petri dish and increasing NA. This is super allowed, but I shouldn't wait until here. It should be in the background, yeah?
Mm-hmm.
Because I'd like, in the method, I'd like to see the steps. I don't need to go over explanations why you're doing this. You know what I mean? It's so misplaced.
Yeah.
Better to write it in the beginning. The seeds are also germinated for 10 days. Again, repeating, right? Why are you repeating this again? Right? Instead of the original. Oh, see? Oh, this is um why I'm saying this. This is contradicting. The seeds were also germinated for 10 instead of original 15. So you did this due to time constraint. It's not the ideal one. It's because like you're running out of time. Right?
Yep.
So what is this? Is this gonna so because you said the control, right? You control this.
Mm-hmm.
I'm not saying it's wrong. I'm saying that should be written. I mean, if you have um, edited the protocol, give me a or give us a compelling reason. Why not 15? Right? Saying due to time constraints doesn't really give me, it's not a compelling reason, is it?
Yeah.
I'm just running out of time or I just don't want to. You know what I'm saying? I'm just being I'm just being kind of objective about it, right? It's like, for example, if I'm giving you money, right, and you said that you need, if you need 1,000 yen, but I said, you know what, I don't know, I just don't feel like giving you 1,000. I just give you 500. But why, right? You're gonna ask, like, why? Why did it? When I said that I needed 1,000, why are you giving me 500? Right? At least give. I should give you a reason why 500 is enough.
Mm-hmm.
Cool? Because again, you mentioned, and again, I'm not saying that it's wrong. It's just that saying that for time constraints is not strong. Okay? It can be like 15. I'll give you like a more realistic way of saying it, yeah? If this person, if Ma et al did this at 37 degrees, which is too hot, right? The temperature, maybe this is done somewhere in Central America or somewhere that is a tropical region, right? Where tropical corn anyway um, grows in tropical regions. So in the tropical region, the temperature is within uh, from months where the temperature is 30 to 35 degrees. Okay. But because I did this at a very, very hot summer in Japan, where temperatures will reach above those temperatures that was grown, um, it will not stress, the temperature will not stress my um, the roots. I will put them for 10 days instead of 5. So there is a 35% decrease of time exposure. You see how it is more ideal?
Mm-hmm.
Do you see how it's like, oh, okay, it's justified why it got less? Because I mentioned in the control variable that temperature must be controlled. See, the thing here that the temperature, I don't even know what room temperature we're talking about here. Is it 25 degrees? Is it 38? Is it between 25 to 30? Okay, what month did you do this?
I think it was like May,
So
probably.
it's warm. Okay, so it's warm, right? It's not winter time in Japan just yet, right?
Mm-hmm.
Would you know what is a room temperature in May in Japan, or at least in Tokyo? You can look it up. You can look it up later. Maybe it's between ballpark figure for me. Maybe it changed. Maybe it's 28. Maybe it's 20. Maybe less because it's May. It's not June, right? So maybe it's 20. Let's say 20 to 25.
Yeah, something around that
Something
range.
similar, right? So that would be a similar range, right? So again, just give me a compelling reason, or give us a compelling reason why it is shortened, not only just because I just running out of time. Okay, there must be a reason. The thing is, you had data, right?
Mm-hmm.
You were able to collect data, so meaning it is still valid if you were able to. Let's check. In measuring the radical, procedures replicated another experiment on soybean. Huh? Published guides used to create NAA stock solutions. These procedures were replicated in the methodology that they studied similar variables. Okay, so it's the okay, got it. So it's just because of the variables, but basically it's different. Um, because I would be like, why soybean? Soybean is very different from corn. You know what I'm saying?
Yeah.
So I was just kind of taken. I was thrown off. Like what? Okay. Again, these things I appreciate that it's written here, but because you're running out of space, there must be a way that to make this more concise. All right. So I would say please refer, or you can do that, like please refer to um or I referred from this um I referred to this just briefly, you know, and then I change these variables, actually it's better, really, it's so much better before you write your control variables. Okay, because when you introduce your manipulated variable, it should have already been established why you're doing so. You get what I'm saying?
Yeah.
All right, okay, now let's go over your methods. How many steps? Wow, 35 steps, woman.
Mm-hmm.
All right. Okay. Um, repeatable weighing, place the weighing boat. Uh, for the sake of um, for the sake of conciseness and consistency, um, because your lab report is a report of an investigation that you have already done, it would be ideal if your methods is written also in the past tense. Okay?
Yep.
I mean, if I reading it, for me, it's not bad, but I'm saying just to be consistent. It can be better, but if you like it like this, I think that's good. All right? 35 steps to me is a little overkill. So I suggest that you review your methods, that it's like, for example, place the weighing boat over a scale. Is this is this supposed to be like a protocol? So maybe you could say, by using a weighing boat, measure this, right?
Mm-hmm.
Because it's one step. And I explained to you this is the process of measuring by using a weighing boat. So just review this in a way that It will be more concise, it's easy to follow. Because if I were a student and I have 35 steps, I'll be like, geez Louise, I don't want to do this lab. There's 35 steps, right? It just I don't know, it it's not gonna help other students repeat your lab report, because it's also it's a gauge. The teacher also gauges how repeatable your method is. Okay, it says here, the description of the methodology of collecting and selecting allows the investigation to be reproduced. So giving a person 35 steps to do your lab is a little bit too much. You get what I'm saying?
Mm-hmm.
Okay, so this could be improved. All right. Let's go over your performing the investigation, conceal, transfer the petri dish. Oh, we're not done. Oh, wait a second. Oh, okay. So it's a broken. Come to think of it, it's a broken. Okay, is this necessary? Is it actually necessary to show the transfer to the petri dish?
Uh,
It's good, but again, you're saving space. So maybe you can put this in the appendix, okay? So
okay.
anything that would substantiate, you think that is any images or any tables, anything that would substantiate your work, but it's over the 3,000 limits or 12 pages, you can put that in the appendix, okay? And you can do that after citation. So this is your citation right here. This is your references. And then I would put a place here that says appendix. Okay. And in the appendix, you can put figure A, figure B, whatever. Images. These are the images for my methodology, etc. Okay. So review that as you go along with your revision. Okay.
Mm-hmm.
Next, manipulated variable. NA of watering. Okay, so this is your NNA stock. All right. Wait a second. You should have 5 of these, right?
Yeah, I had like it's like I didn't have a lot of photos back then. I have like
Mm,
they're stored in the lab, so I was like planning to like if I had time, I was planning to
okay.
like, take it out and take a photo.
Okay. All right. And then the dependent variable is the radical length. Okay. Measured by the rule. This is the ruler that you used. Okay. And it is in centimeters, I suppose. Is it centimeters or millimeter? Yeah, centimeters. All right. Changes made post trial. During the trial, I realized 0.1 mole of sodium hydroxide was ineffective. So I replaced it with 1 mole. Okay. I also omitted steps. So you see how you made some changes here,
Mm-hmm.
and then later you're gonna say that you changed something here. Is it really necessary that you do it twice in a different place?
I could combine it.
Yeah, you can combine it, right? Is it okay? Because it's making it like you said this, and then the procedure, and then we go back. It's lacking fluidity.
Mm-hmm.
Okay. All right. So just take note of. Are you writing this down somewhere?
Yeah.
Because I haven't been writing this down. All right. Okay, so let's go over your table. So this is your risk assessment. This is part of the methodology. All right, safety and ethical considerations. All right, so safety. This is a very nice way of doing so, but okay, hazards. Okay, cuts, safety considerations. I will adopt safety measurements, organize label solutions. Okay. Ethical amount of water used in experiment, potential loss with minimizing waste. Okay. Ethical meaning this amount of water used in the experiment is actually more of sustainability, right? Sustainability is more of an environmental issue. Okay, ethics is more of, are you hurting anyone? Are you hurt, is there anything that has been killed in this experiment?
Plants. Do they count?
Oh, well, you got seeds and it's abundant, so it's not necessary. I mean, like, it's
Okay, then.
more of environmental. You didn't really kill a plant, right? You didn't really have evidence that the plant was killed for this experiment. So I would, it's actually okay to say, I'm going to take this out here and put it somewhere here. So perhaps you could say that this is for sustainability reasons. Hey, what's happening? How come it didn't paste? Paste. What? Wait a second. Let me do that again. Oh, I'm messing up right here. Hey. Wait a minute. Let me just check what's going on. Let's check. How long have we been recording?
It's an
Oh,
hour and 16 minutes.
oh my god. Okay. Well, I have to, we are only still on the halfway point,
Mhm.
or we're still in the first pace. But it's okay because this is good. This is good. What did I say? How come it's not pasting? It's not pasting. All right, let's have a little break, okay? Shall we? I'm just gonna stop this. All right, wait a second.